Every second, somewhere on the planet, someone is slurping a cup of instant noodles. But almost nobody has seen how a handful of wheat grains becomes that perfectly springy noodle block waiting under a foil lid, or why it can survive on a shelf for months and still cook in just 3 minutes. Inside Nissin's modern factories, that transformation looks less like a kitchen and more like a fusion of a flour mill, a chemistry lab, and a robot warehouse. It's a place where wheat is scanned by lasers, dough is stretched by steel rollers the size of car tires, and tens of thousands of noodle blocks are fried, cooled, and packed every single hour. If you enjoy going behind the scenes of how everyday icons are made, subscribe and stick around, because what happens between the grain silo and your bowl is far more intricate than it looks. It all starts with wheat. Not just any wheat, but carefully selected varieties chosen for their protein content and gluten strength. Trucks unload tons of grain into huge silos, where the wheat is cleaned, destoned, and passed through magnets and air jets to remove dust and metal fragments. Sensors check moisture and quality. For Nissin, consistency is everything. The noodles you eat in Tokyo, São Paulo, or New York should feel the same between your teeth. And that begins with controlling the raw grain. The cleaned wheat is then milled into flour. Inside a milling line, steel rollers crack the grains open, separating the bran, germ, and endosperm. The endosperm is ground again and again into a fine, pale flour. This flour doesn't go straight into noodles yet. It's blended with other flours and sometimes starches to hit a precise specification. Not too weak, not too strong, with just the right ability to form gluten and hold its shape during frying and drying. Think of it as designing the noodle's personality before it even exists. Now comes the first transformation. Flour into dough. Huge mixers receive flour, water, and a carefully measured alkaline solution containing kansui, the traditional magic behind many Asian noodles. Kansui, usually a blend of sodium carbonate and potassium carbonate, raises the pH of the dough. That's what gives instant noodles their subtle yellow tint, their characteristic springy bite, and their resistance to turning mushy in hot water. Salt and sometimes a little oil are added too, helping structure and flavor. Inside the mixer, paddles knead the ingredients until loose flour clumps together into a rough, shaggy dough. Unlike bread, this dough doesn't need to puff up with yeast. What it needs is structure. The dough is rested in large troughs, allowing the gluten network to relax and align. Then it's fed into a series of rolling machines. Imagine a thick, uneven slab of dough entering one end, and a long, smooth sheet emerging from the other, thinner each time it passes between the rollers. This sheeting process can involve 6, 8, even more sets of rollers, gradually compressing and stretching the dough. Each pass lines up gluten strands like fibers in a rope, giving the final noodle its chewiness and strength. Once the dough sheet reaches the right thickness, it meets the cutting rollers. These are cylinders etched with razor-like grooves, spinning in perfect sync. As the sheet passes through, it's sliced into dozens of parallel strands. The spacing and shape of these grooves determine whether you get thin, delicate noodles or thicker, more robust ones. But Nissin doesn't just cut straight lines. The strands are often gently waved as they move along, creating that familiar curly instant noodle shape. This isn't just for looks. The waves create more surface area, helping the noodles cook faster and hold on to soup better. Freshly cut noodles are still raw dough. If you drop them straight into a broth, they'd fall apart. So the next step is steaming. Long conveyor belts carry the tangled strands through a tunnel where hot steam surrounds them. Inside, starch granules swell and gelatinize, and the gluten network firms up. In a matter of minutes, the noodles go from pale, flexible dough to fully cooked, bouncy strands. At this point, they could be eaten, but they'd spoil quickly. The true genius of instant noodles lies in what happens after steaming. As the steamed noodles exit the tunnel, they're portioned into individual servings. Mechanical arms and guides gently fold or curl each cluster of strands into a mold, shaped like the familiar rectangular block or the rounded cake that fits into a cup. This shape isn't random. It's designed for even frying or drying, easy stacking, and the efficient packing. Beneath the molds, a conveyor moves steadily toward one of two possible destinies: deep frying or hot air drying, depending on the product line. For classic fried instant noodles, the blocks are lowered into huge baths of hot palm oil. The temperature is carefully controlled, usually around 140–160 degrees. In less than 2 minutes, something dramatic happens at a microscopic level. The water inside the noodles rapidly escapes as steam. leaving behind a network of tiny pores and tunnels. The surface becomes lightly crisp, the interior turns dry and stable, and the oil coats and infiltrates the structure. This porous sponge is the secret to 3-minute cooking. When you later pour hot water into your bowl, it rushes back into those pores, rehydrating the noodle almost instantly. Not every noodle is fried. Many modern lines also produce non-fried noodles using hot air drying. Instead of oil, powerful fans and heated chambers blow hot air over the steamed blocks for a longer time, gently removing moisture until the blocks reach a low water content. These noodles tend to be lighter in fat and slightly firmer in texture, but the principle is the same. Create a dry, porous structure that can be revived quickly in boiling water. Whether fried or air-dried, the target moisture level is usually below 10%, low enough to prevent bacteria and mold from growing during months of storage. While all this is happening, another part of the factory is busy creating the soul of the product: the soup base and seasoning. Industrial kettles simmer concentrated broths made from chicken, pork, seafood, vegetables, or soy. These liquids are then reduced, spray-dried, or blended with powders like salt, sugar, spices, dehydrated vegetables, and flavor enhancers. The result is a precise seasoning mix, portioned into small sachets. In cup noodles, powdered soup, dried toppings, and sometimes liquid sauces are dosed directly into the cup before or after the noodle block drops in. Now the choreography gets even more precise. Packaging lines bring together noodle blocks, cups or pouches, seasoning packets, and lids in a tightly synchronized dance. For cup-style products, a forming machine shapes paper or plastic into cups, which move along a conveyor. A robotic arm or gravity-fed chute places a noodle block inside each one. Above the line, dispensers drop in dried vegetables, meat bits, or flavor oils. A foil lid is sealed on top using heat and pressure, often followed by a plastic overwrap for hygiene and durability. For bagged noodles, the block and seasoning sachet slide into a printed plastic pouch, which is then sealed, cut, and date-stamped. Throughout the factory, quality control is constant and ruthless. Random packs are opened and weighed. Noodles are checked for breakage, color, and texture. Oil quality is monitored and filtered. Metal detectors and X-ray machines scan finished packages for foreign objects. In laboratories on site, technicians cook sample noodles to test rehydration time, firmness, and flavor. If a batch doesn't meet the standard, it doesn't leave the building. Nissin's global reputation rests on the idea that every cup or pack should taste like the one before it, whether it's produced in Japan, the United States, Thailand, or Brazil. Behind this polished process is a story that began in a small shed in Osaka in 1958, when Momofuku Ando invented chicken ramen, the world's first instant noodle. Back then, he manually flash-fried noodles in oil to dehydrate them quickly. Today's factories are the industrial-scale descendants of that simple insight. Cook the noodle, dry it fast, and make it come back to life with hot water. Over decades, Nissin has refined everything around that core idea: ingredients, machinery, packaging, and logistics, to feed millions every day with astonishing efficiency. The real twist is that what looks like a cheap, simple snack is actually the result of fine-tuned engineering and food science. The thickness of the dough sheet, the pH of the kansui solution, the seconds spent in steam, the temperature of the oil, the size of each pore in the dried noodle block. Every parameter is measured, adjusted, and locked in. Change one variable too much, and the noodle turns soggy, brittle, or bland. Get them all right, and you create something that can sit on a shelf for a year, then transform into a hot, satisfying meal in the time it takes to scroll your phone. And that's the hidden power of a modern instant noodle factory. It compresses time, months of agricultural work in wheat fields, hours of simmering broth, and the labor of countless hands are condensed into a product that asks only for boiling water and 3 minutes of patience. From grain to bowl, the journey is long, complex, and meticulously controlled, even if all you ever see is the moment you peel back the lid and watch the noodles rise to the surface. If you want to really see how all these steps come together on the factory floor, the machines, the steam, the oil, the robots, don't miss the next video on Inside a Modern Instant Noodle Factory. It turns this process from theory into moving reality. See you there.